Okay, so the last thing we're going to talk about is another way that we can measure angles and talk about angles. And this is the way that we're going to use predominantly kind of throughout the rest of the year and then when you go into calculus. So it's called a radian. A radian is equal to 57.2958 blah 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 degrees. So it's this big chunk. I have a nice little video for you, so it's going to show you what a radian is. So it's the radius comes out, wraps one time around the circumference, and that space that it makes, that's 1 radian. So if you look at it again, there's radius, comes out, wraps around, goes around the circumference of the circle, connect back to the center, that's 1 radian. So it's a nice little just chunk of the circle. Now, no matter how big or small your circle is, you're always going to have a radian equal to 57.2958 degrees. So it's going to stay the entire time. So with that idea, there's 1 radian, and we're going to wrap that again. There's 2 radians, 3 radians, and a smidgen. 3.14 pi radians is equal to 180 degrees. It's going to be a big thing that we're going to use today. So watch that again, 1 full radian, the second full radian, third full radian, and then just that little smidgen, that gives me 3.1416 pi radians is equal to 180 degrees. So on your paper, when we talked about degrees, we went back to that picture that we had at the beginning. This was 0 degrees, this was 180 degrees, so halfway through would be 90 degrees. If I go another 90 degrees down, that's 270 degrees, and then my full rotation is going to give me 360 degrees. Radians we just saw started at 0 radians. When it went all the way over to what would be 180 degrees, that was pi. Okay, and that's going to be our main conversion factor. The idea that pi radians is equal to 180 degrees. So I can divide each side by pi to get my first conversion factor, so 180 degrees over pi. Or I can divide each side by 180 degrees, so or pi over 180 degrees. We can go back and forth between degrees and radians, and we're going to do that today and tomorrow a little bit too. The 2 conversion factors that you're going to use are these bad boys. So the first thing we're going to do is convert to degree from radians. The way that I know that something is in radians, there's going to be 2 things. Typically, you're going to see a pi, and that's going to tell you it's in radians. The other thing is there's no degree symbol. So the number 2, when we're talking about angles, that's a radian. If I do 2 degrees, now it's in degrees. But when I have just that number 2, that's a radian. I want to convert this into degrees, so what I need to do is have degrees in the top, which means pi goes in the bottom, 180 degrees goes in the top. So if you go back and look, I'm using this conversion factor right here. I want to get it in degrees, so it needs to be in the top. This is non-calculator, so I want you to try to do as much as you can without your calculator. Your pi's cancel, and then we can look at this. I can look at 9 and how many times it goes into 18, which is 2. Bring along your 0. It's going to be 1. 13 times 2 is 26. Bring your 0. 260 degrees. Same with this guy. I want to get it into degrees. Degrees goes in the top, which means pi is in the bottom. 180 in the top. Your pi's are always going to be the easy thing for you to cancel. Both of these we can divide by 2, so it's going to give me 18 and 90. Divide each by 9, so it's going to give me 2 and 10. Divide by 2, that's going to give me 1 and 5, so it's going to be 35 degrees. We're going to do the same. This is converting to degree. Now these are still radians. Now we're going to call these something like, this would be called a decimal radian, just because it has no pi. Not really a huge deal, but just some stuff to get familiar with. We still want degrees to go in, so 180 needs to go in the top over pi. The exact answer would be 360 degrees over pi, but you do have a calculator, so we can go ahead and divide that out. It's going to give me a grand total of approximately 114.59, and we'll go out 3 places, 2 degrees. 1.3 is going to be the same exact idea. 1.3 times 180. This is going to be 234 degrees over pi, exact answer, which is approximately 74.485 degrees. So that's converting into degree from radian. And from here, we're going to go the opposite direction, which is going to be from degrees into radians. So this time, I want that radian to be in top. Radian is always going to be your pi. Degree is going to go in the bottom. This is non-calculator active. You can cancel your zeros. This is 11 pi over 18. No units go out here. If you want to, you can write radians, but you don't have to. Do the same thing with 172. 180 in the bottom, pi in the top. Now on this one, it's going to be a little bit more work. I'm going to start with something small and just divide each by 2. So that's going to take me down to 90. Divide by 2 should take me down to 86. I'm going to divide by 2 again, so I'm going to get 45. And that should be 43. So this is going to be 43 pi over 45. And you can write radians if you want to. These are calculator active. Let's make this one a little bit more fun. Let's make this 19. So 61 degrees, 19 minutes. We're going to convert these into radians. Now, the crappy part is you have to do that conversion factor we just talked about. So we're going to keep 61, but I need to convert it into its decimal. So this is going to be 19 minutes. I want to convert into degrees. So there's 1 degree every 60 minutes. So 19 divided by 60 gives me a grand total of 0.3167. 3167. Same conversion factor though. So we're going to take this lovely angle, multiply that by pi, and divide that by 180. And this is going to give me approximately 1.07 radians. Same thing with this guy. This is going to be 100 degrees, but we need to take this 49 and change it into degrees. And we need to take this 50 seconds and change that into degrees as well. So 1 degree, 60 minutes, 1 degree, 3,600 seconds. Should give you 0.8167. And this is 0.0139. Add those two together. So I'm going to get 100.8306 degrees. Convert this into radians. We're going to use our same exact conversion factor we've been using. This should be approximately 1.7598, so it's going to round to 1.76 radians.